So this is the last day that we're going to go over new information, but before we start on looking at circles, I'm going to go over a couple application problems from material that you were just looking at and taking a test on today, and that will be on the final. So this is a good review for the final also. So I pulled up a question from my math lab, and it says, the population of the region is decreasing according to the formula. So we have an exponential formula. Y is equal to y sub 0, e raised to the negative 0.026t. In this formula, that t is going to represent your years. Y sub 0 is the initial population at time 0. And if the size of the population in 2002 was 11,770, use the formula to predict the population in the year 2016. Okay. So a lot of the problems, when you see them on my math lab, don't get overwhelmed by them, because this basically tells you a lot of stuff. It tells you where you're going to plug stuff in, and some of the problems on the test are going to do that too. So right here it says t is time, right, in years. Y sub 0 is the initial amount at t equals 0. Okay. And then it told us what the population was. And so the population was 11,770. So this year, this is going to be our initial amount. Is the 11,770. And because that was the amount given in 2002, this is t equals 0 in 2002. And t is equal to the years since 2002. And so we're just going to go back in and we're going to plug in what they gave us right here for y sub 0. So we have y is equal to our initial amount, which was 11,770, e raised to the negative 0.026t. And so now we have that equation. We can answer the question it has for us. So if it said, what is the population in a certain year, which it did, we're going to figure out what t is in that year and just plug that value in for t and plug that into the calculator to get a number. If it said, find the year the population was a certain amount, then we would have to plug in that certain amount, that new population, to y, and then figure out what t is. And that is a good problem because that uses rules of logarithms that we were doing in this section. So let's first look at the population in 2016. So all you're doing is, so we're figuring out how many years we have since 2016 and 2002. So in this case, t is going to equal 12. And so you're just going to go back into the formula that we have and plug in 12 for t. Okay, so doing that. Okay. So you just got to be careful on the type of calculator you have and how you plug it in. So my calculator, I could just plug in 11,770 times. I have a button that has E and it doesn't open parentheses, so I can just put in the exponent. So negative 0.026 times 12 close the exponent parentheses off and push enter. And we get that the population in 2016 was approximately 8,615. Okay, so that's less than the original population. And so my guess is what it was saying, it was decreasing, and it said it was decreasing. And I knew that too. When I looked at that value, this coefficient in front of time, that is the growth rate. And so if that's negative, it's a decreasing function. And if it's positive, it's increasing. So let's go one more step further in this question, and let's answer, when will the population reach 2050? Okay, so this is where we know what our Y value is, but we don't know what T is. And so we're going to plug in 2050 is equal to our initial amount, our 11,770, e raised to the negative 0.026. And we're trying to figure out what T is. Okay, so solving exponential equations, you want to get the exponential piece, the piece that has the base raised to the power with the variable exponent. We want to get this by this itself. So we don't want that 11,770 multiplied to that e. And so we're going to need to divide both sides by that 11,770. I might reduce a little bit. I'm not going to put it in the calculator though and put any estimate decimal form until I'm done. So with exponential problems, it does really make a difference if you are estimating while you're doing the problem. And so we got our exponential piece by itself. We want to bring down the exponent from the e so that we can solve for that variable. And so we want to take either the log or natural log of both sides of our equation. And since we have e, it's easier to take natural log because that's just actually equal to the exponent. And so if we take the natural log of 205 divided by 1,177 now, this is equal to the natural log of this e, but natural log of e again is just the exponent. So I'm not going to write that step down right here. Okay, and so we're almost there. We just got to get t by itself. We can divide both sides by 0.026. And so t is equal to the natural log of this 205 divided by 1,177. That number all divided by 0.026. And so if they ask for the exact answer, this is what it is. But to us, that probably doesn't mean too much. And so if they asked you to estimate it, we're going to plug it into the calculator. And so a natural log of 205 divided by 1,177 in parentheses on that natural log, and then divide by 0.026. Okay. Well, that doesn't make sense to me. Okay, I know why. I'm getting a negative number. And that wasn't making much sense to me because how can time be negative? Notice I didn't bring down my negative with the exponent here, negative with my exponent here, negative with my exponent here. And so if I do that, and I'm going to get, it's going to happen and it's going to occur in 67 years from 2002. So if I wanted to know the exact year, that's going to give us 2069. So if things continue to decrease at that constant or at that rate, in 2069, the population will reach that 2050. Okay. So you definitely should be able to do exponential problems. Let's look at another example. I'm stuck in this color unless I leave this page and come back. Okay, so let's say you have some function. We have, let's say, a cost function for a company. And I'm coming up with this in my head, so it might not be as pretty as some other things. Is C of X, let's say, is X squared minus 10X plus 16. And let's say we want to find let's say to create X units of a product. And we want to find when is the cost well, that doesn't really make sense. How about revenue? Let's say the revenue function. And let's call it R of X. So let's say it's the revenue to create for selling X units. And we want to find when the revenue is positive. Okay, so basically it's telling me I want to find when R of X is greater than 0. And so I need to look at this and set it up. And so we have x squared minus 10x plus 16 is greater than 0. And so this is a nonlinear inequality. This is where we had to set and find our critical numbers, values where it was equal to 0. So doing that, I would factor, if possible, which I can. And so this is x minus 8 times x minus 2 is greater than 0. So this is when x is either 8 or x, critical numbers I was finding when it was equal to 0, sorry. Or x equals 2. Okay, so remember, x is the number of units being produced. So really in our problem, having a negative number of units being produced doesn't make too much sense. So I'm going to just put a 0 there. So we want to choose a number less than 2 and plug it into our inequality to see if it's true or false. So if we plugged in 1, r of 1, that would have been 1 squared minus 10 times 1 plus 16. So 1 squared minus 10 is negative 9, negative 9 plus 16 is 7. This is greater than 0. So this is a true statement. Choose a number between 2 and 4. So if we plugged in 3, we would have 3 squared minus 10 times 3 plus 16. So that's 9 minus 30. That would be negative 21. Negative 21 plus 16 is negative 7, which is less than 0. So this is false. And then one more, if we chose, let's say 9, plug it into r of x, we get 9 squared minus 10 times 9 plus 16. So 81 minus 90, that's negative 9. Negative 9 plus 16 is positive 7, that's greater than 0. Okay, so the company would have positive revenue if they're selling between and including 0 and 2 units. Actually, 2 is going to give them 0. So let's see. So r of x is positive. Over the intervals 0 to 2, union 8 to infinity. So now we're going to look at some variation problems. So this one is pretty straightforward. It just kind of wants you to write out what the generic equation would be. And so in this one, it says write an equation to describe the variation. Use k as the constant for the proportionality. Okay, so all we're doing is we're writing out the variation problem, and it says y varies directly. Whenever you see this y varies or something varies, you know it's that whatever it told you equals k and then whatever. So y varies, I know here then y equals. I'm always going to put that constant k after I put the equal sign for variation problems. Okay. Then it said directly with Z. So when it says directly, that's multiplication. Jointly, that's going to also be multiplication, but you're going to join it, multiply multiple variables. Inversely means division. So those are only three words that you're going to hear, either directly, jointly, or inversely. So directly is multiplication again, so K times Z. Inversely, that's division, so over, and then it told me P squared. So doing these variation problems, really all you're doing is you're going to read through your problem. You're going to try to figure out, you're going to first need to come up with this generic equation. They're going to give you enough information on something that you can plug in all the variables except for K so that you can figure out what K is. The next point, they'll ask you a question about the problem. So you then have the generic equation with what K is for that particular word problem, and you can answer anything about it. So let's pull up one like that. Do it this way. Okay, so right here we have the maximum weight of a rectangular beam varies jointly with the width and the square of the height and inversely with the length. Okay, again, it's really wordy. A lot of times too, it's helpful to, let's put in variables. So the maximum weight a rectangular beam can support. Okay, so this is talking about weight, right? So maybe we can put, I know it's also maximum weight, but this varies jointly. So I know right now I have W equals, it's varying, so it's a variation problem. I'm putting my K in there. Darn it. Okay, we're not gonna have color this time. So K jointly, that means multiplication with the width as its width. I like that to be W also. So maybe because this is maximum weight, we can make that an M. Okay, so very jointly with the width and the square of the height. So H is the height and H squared is how we're going to write that. And then it's inversely with its length. So all over some RL. Okay, so here's our generic equation. And now it's going to bring us through so we can pull, put all the numbers in and figure out what K is. So if a beam is 1/3 foot wide, okay, so this is equal to K. We have our width 1/3, so I'm going to place it in here. 1/4 foot high, so we have our height. And so height goes in the numerator and it's squared, so 1/4 quantity squared. And 18 long, so the length is 18 feet, so that goes in our denominator. And it can support, we have our M value, 20 tons. Okay, so from here we want to solve for K. And so doing that, let's multiply both sides of our equation by 18 to clear our fraction. And so we get 20 times 18. Well, 2 times 18 is 36 plus the 0 after because it was 20 equals K times 1/3. And 1/4 times 1/4 is 1/16. So this is 360 is equal to K. 1/3 times 1/16, that is 1/48. Multiply both sides by 48, we get that K is equal to 17,280. Okay, so we now have the equation that we can use to answer any question they throw at us. So we have the maximum weight, M is equal to K, but now we know what K is, 17,280. Our width times our height squared, all over our length. And so going back to see what they are asking now. So how much a similar beam can support if the beam is 1/4 wide, so W is 1/4, 1/2 foot long, and 1/2 foot high and 14 feet long. Okay, so we have the width is 1/4. So M equals 17,280 times the width 1/4 times the height, which was 1/2. We have to square our height all over our length. And our length was 14. So I have 17,280. 1/4, well, 1/2 squared is 1/4 too. So 1/2 times 1/2 is 1/4. 1/4 times 1/4, so that's 1/16. Divided by 14. So see if that 17,280 is divisible by 16. It is. It goes in 1,080 times, all over 14. Excuse me. And this is about 77, rounding it. And if you looked back, the maximum weight previously was in terms of tons. So we can support up to about 77 tons. Okay. Let's move on to circles. Okay, so one of the last topics is circles. Circles, there's a couple different forms that a circle can be written in. If a circle is written in a standard form, the standard form of a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So if we can have our equation in this form, then we can tell a lot about the circle. We can tell what the radius is, and we can tell what the center is. So the center is at the point h, comma, k. So kind of like when we had vertex form for our parabola, we could tell what the vertex was. Remember the piece that was squared was always the opposite side. So same kind of idea with circles. So both our h and k value in this case are the opposite signs of what was inside that parentheses. And the radius is equal to r. So the other side is quantity squared. So to get the radius, we're going to have to figure out what the square root of that is. Okay, so let's just start one where it's already in standard form and it asks us to graph it. So if it says graph x minus 2 quantity squared plus y plus 4 quantity squared is equal to 9. Okay, so looking at this, you should be able to identify where the center is and what the radius is. Okay, so our center here, again, opposite sign. So our h value, this is going to be just 2, and our k value is going to be its opposite, so -4. Our radius, well, r squared is 9, so the radius is 3. When we took the plus or minus there, we didn't, taking the square root of both sides, we didn't include the negative. But normally when you're solving something like that, you have to put the plus and the minus there. So our radius is equal to 3. Okay, so now when we're graphing this, I would first plot my center. So I'm going to go to left or right 2. And I'm going to go down 4. Okay, so once you've gotten the center, then you want to go up, down, left, and right your radius. So if I go up, and it doesn't matter what order, if I go up 3 from my center, so right here, this is 1, 2, 3. If I go to the right 3, from my center, I'd get a point right here. I'm going to go to the left 3. So it's going to hit -1 and have a point right here. And then if I go down 3, I get a point here. So now we have 4 points on the circle. We can connect them and make a circle. Okay. Best I could do. Okay, so we went up, down, left, right from our center, unit 3. Okay, so if it's not in that form, we have to put it in that form, so it's standard form. So let's say you had the following. You had x squared plus y squared plus 2x minus 6y plus 7 equals 0. Okay, so I can tell this is a circle. The reason I can tell this is a circle is that we both have x squared and y squared in our equation. Later on, when you get into further in algebra, you'll notice that they have to actually be the same number coefficient in front of the x squared and y squared to be a circle. If they're different, then you're going to get into ellipses and hyperbolas, but that is for a different course. So for now, that number in front of the x squared and y squared are always going to be the same number, same sign in order to be a circle. And that's just going to be given to you like that. Okay, so we want to put this in standard form so that we can graph it. So first step, we want to group our x terms together, we want to group our y terms together, and we want to get our constant to the other side. Okay, so doing that, I'm going to rewrite this. We have x squared plus 2x. Let's leave a space here. We really want to notice this is x minus h quantity squared. We've been doing this a lot during this course. We want to complete the square to make that a perfect square. So we're going to actually put a plus something here. I'm going to group my y terms. So grouping my y terms together, I have y squared minus 6y. But again, I'm going to want to do this. I'm going to want to add some constant here to make this a perfect square. This is equal to, so getting the constant on the other side, I'm subtracting 7 on both sides of the equation. And so I would get -7 here. But remember, if we're dealing with equations and we add something to one side, we got to add it to the other. So I had added some constant here to make this, my whole goal is to make this a perfect square. I'm going to have to add it on the right-hand side. I added some constant here to my y term so that it would become a perfect square. I'm going to have to add it over on the other side. Okay, so recall, to complete the square, you're looking at the same number that you're going to add to give you that b term. You're going to square it. So the same number you're going to add to get 2 is 1. So 1 plus 1 is 2. So 1 times 1. So the number that we're going to add to make this a perfect square is a 1. So I have to add 1 on the other side. Okay, so the same number that adds to itself to get -6 is -3. -3 times -3 is +9. So I have to add 9 to make that a perfect square. Okay, so we just manipulated this so that we can rewrite these first 3 terms as some quantity squared, these last 3 terms on the left-hand side as some quantity squared. So the same number that multiplies to give you 1 and adds to give you 2 is 1. So we can rewrite this as x plus 1 quantity squared. And y squared minus 6y plus 9. So the same number that multiplies to give you 9 and adds to give you -6 is -3. So this is y minus 3 quantity squared. And then sum, -7 plus 1 is -6. -6 plus 9 is 3. So maybe I should put this here. Complete square on x and y terms. And so from here, we can tell what our center is. Opposite sign, so this is -1, +3. The radius, well, it's equal, r squared is equal to 3. So r is actually equal to the square root of 3. And that's 1 point something, let's see. So approximately 1.7. So from here we can graph. So if we go to the left, -1, and we go up 3. So we're going to go left, right, up, down about 1.7. So just estimate it. So from this point going down 1.7, that's going to be about here. Go up 1.7 would be about here. 1.7 this way. 1.7 this way. And so we get our circle. So this section I don't think is too bad. I mean, if you're okay with completing the square, and we, like I said, we've been doing it over and over on this course. We did it to solve putting things in perfect squares so that we can use the square root method of solving equations. We used it when we were putting parabolas in vertex form. Now we're using it for circles. Okay, so we're going to look at another example and put it into vertex, or not vertex form, standard form for a circle, and graph it. So again, you're going to group your x terms together, group your y terms together, get constant on the other side. So rewriting this, I can rewrite this as x squared plus 2x. I know the whole point is I need to get this as a perfect square. So I'm going to have to add some number here to make that a perfect square. So I'm just going to leave a spot. Grouping my y terms together, I got y squared, so plus y squared, plus y. I know again, I'm going to add something here to make this a perfect square. So let's leave a spot for it. Equals. And so we need to move this 1 over to the other side. So subtracting 1, got -1. But if we add something to one side of the equation, we got to add it to the other. So you're thinking to yourself, what is the same number you would add to give you 2? Well, that's 1. And then 1 squared is 1. So we're going to add 1 to both sides of the equation. So over here, the same number that you would add to itself to get 1, that's actually a half. So a half plus a half is 1. And so this number here, 1/2 times 1/2 is 1/4 plus 1/4. So these are now perfect squares. The first one is x plus 1 quantity squared plus, so the same number that multiplies to give you 1/4 as to give you 1 was the 1/2. So y plus 1/2 quantity squared is equal to, well, -1 plus 1 cancels, and so we're just left with 1/4. So our center, this is opposite sign, -1, opposite sign, -1/2. And our radius, well, r squared is equal to 1/4. So take the square root of both sides. Radius positive, so r is equal to 1/2. So you had x squared plus y squared plus 6y plus 2 equals 0. So again, let's put this in standard form to figure out what the center is and the radius. So notice on the left-hand side, there's only one term with x. So that's technically a perfect square. So we really don't have to add anything here. For the y terms, we have y squared plus 6y. We're going to have to add something here to make that a perfect square. This is equal to, get the constant on the other side, let's subtract 2. So technically, if this helps you to look at it this way, this x squared, usually you wouldn't look at it this way, but if it helps you, this is x plus 0 or x minus 0. Doesn't matter, plus or minus, quantity squared. Plus, okay, so the same number that you would add to get 6 is 3. So 3 times 3, the number that we're going to have to multiply, 3 times 3 is 9. So we have to add 9 on both sides. So then we just wrote this as a perfect square. So this is y plus 3, quantity squared, equals 7. So our center is equal to 0, negative 3. And our radius is the square root of the other side, which is 7. So square root of 7. Okay, so let's say that you were given information about the circle. You weren't given an equation or anything, and you were asked to find the equation. So find the equation of the circle. Given the following information. Okay, so let's say they gave you that the center is at the origin. And it passes through 4, 7. So in order to find the equation of the circle, we need 2 things. We need to know what the center of the circle is, and we need to know what the radius is. So it already told me that the center was at the origin. So I know my center is at 0, 0. It tells me that it passes through the point 4, 7 though. So if I graphed what I have so far, so I have 0, 0, I'm going to go over 4 and up 7. So I know that looking at this length in here is the radius. So I got to figure out what that distance is. So we need to find the distance between the center of the circle, 0, 0, and a point that is on the circle, 4, 7. So recall distance formula is equal to the square root. You're looking at the change in your x values, x of 2 minus x of 1, quantity squared, plus the change in your y value, y sub 2 minus y sub 1, quantity squared. So just plugging in those numbers. So I have 4 minus 0 squared plus 7 minus 0 squared. So square root of 16 plus 7 times 7 is 49. And so that would give me 65. Square root of 65. Okay, so I know that r is equal to the square root of 65. I know my center is 0, 0. And I know the form of a circle in standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. So I have x minus 0 quantity squared plus y minus 0 quantity squared equals r square root of 65 quantity squared. So x squared plus y squared, this is equal to 65. So we found the equation of the circle given the following information. Okay, so same kind of rules, but this time you're given that the endpoints of a diameter let's say is -1, 1 and 5, 9. And it asks us to find the equation of the circle. Okay, so the diameter is the line that goes through the center of the circle and touches the 2 points on the circle. And so one of the diameters on this circle just happens to be -1, 1 and 5, 9. So if it helps you to picture it, let's graph it. So left 1, up 1. So -1, 1, and then 5, 9. So 1, 2, 3, 4, 5. And so here's the diameter. Well, we know that halfway point in between that diameter, that would give us the center. So halfway point between 2 points on the diameter. Really the endpoints of the diameter is equal to the center. Okay, so we can use our midpoint formula. So we could find a point that was halfway between 2 points by thinking of it as averaging your x values. So sum your x values and divide by 2. Sum your y values and divide by 2. Okay, so our x value, so -1 plus 5 divide by 2 is the x value. The y value is 1 plus 9 divide by 2. So -1 plus 5, that's 4. 4 divided by 2 is 2. 1 plus 9 is 10. 10 divided by 2 is 5. So we now know what our center is. And we have to figure out what the radius is. Okay, well, the radius is either half the distance of our diameter, or now that we have our center, we can look at the distance between our center and one of the points on the diameter, and point of the diameter. So 2, 5. So we just found that was the center. And we now need to figure out the distance. So if we use 2, 5, let's use smaller numbers. So for our radius, find the distance between the center and a point. And a point on the circle. Okay, so we have the point 2, 5. So distance is equal to the square root. So the change of our distance, change of our x values. Okay, so we have an x value of -1 and an x value of 2. So 2 minus -1 squared plus our y value, change in our y value. So 5 minus the x value, or y value of the other one was 1. So 5 minus 1 quantity squared. So the distance is, well, 2 minus -1, well, it's 2 plus 1, which is 3. 3 squared is 9, plus 5 minus 1 is 4. 4 squared is 16. So this is equal to the square root of 25, which is equal to 5. So we get that R equals 5. And so now we can plug it in. Okay, so plugging in our center, we got x minus our h value is 2. So x minus 2, and our k value of the center is 5. So y minus 5 equals our r value is 5 squared. So x minus 2 quantity squared plus y minus 5 quantity squared equals 25. So we just found the equation of the circle that had the radius 2, 5. Actually, we had to figure that out. We found the equation of the circle that has a diameter, endpoints on the diameter, -1, 1, and 5, 9 would have to be this equation.